Hello everyone, welcome back. So in the previous videos we have seen how to solve bisection method and we have also learned how to solve questions using regular falsi method. So let's continue to solve more questions. So the question is, find a real root of 2x equal to log x to the base 10 plus 7 which lies between 3 and 4. Correct to 3 decimal places by regular falsi method. So what is our f of x? F of x is equal to 2x minus log x to the base 10 minus 7. Okay, so this is our f of x. Usually what we do, we find a and b such that f of a into f of b will be less than 0, and this would be our interval. But in this question they have given us the interval, right, that the root lies between 3 and 4. So we have got interval for our first iteration. But we will still have to see which is giving us less than 0 and what is giving us greater than 0, right? So f of 3 is equal to 2 into 3 minus log 3 to the base 10 minus 7, which gives us minus 1.477, which is less than 0. And f of 4, it's 2 into 4 minus log 4 to the base 10 minus 7, which is equal to 0.398. This is greater than 0. So we will always have to, if at all they did not give us the interval in the question, we will always have to try to find out two numbers such that f of a into this f of b should be less than 0. That means f of a or f of b, one of these numbers should be a negative number and the other one should be a positive number. Here f of 3 into f of 4 is less than 0. So this is negative number and this is positive number, right? So multiplication of a negative number and a positive number is a negative number. So usually we will have to find out two numbers in this way, but here since they have given the interval, it is fine. So our first iteration is, interval is 3, 4, right? This is a and this is our b. So f of a was giving us less than 0 and f of b was giving us greater than 0. And now we will have to find out our xi. So in regular falsi method, in our table, the first column is I, it's the iterations. So in some questions they might ask us to do some 3 iterations or 4 iterations. So first column would be I, second one is our interval, and third column would be xi. So in regular falsi method, xi is a into f of b minus b into f of a by f of b minus f of a. In our bisection method, what is xi? Xi is a plus b by 2. So in regular falsi method, I am trying to tell again and again. So in regular falsi method, what is our xi? Xi is equal to a into f of b minus b into f of a by f of b minus f of a. So now let's find out x1. So first iteration, no, so it's x1. So we know a is 3. So substituting 3 into f of 4 minus 4 into f of 3 by f of 4 minus f of 3, which gives us 3.788. Now what is f of 3.788? We got our new x value as 3.788. Now if we find out f of 3.788, this is equal to minus 0.002, which is less than 0. So if we got our new x value, if it is giving us less than 0, so in our previous interval, whatever was giving us less than 0, we will replace that with a new x value. So in the previous interval, 3 was giving us, f of 3 was giving us less than 0. So here also f of 3.788 is giving us less than 0. So we will replace this with a new x value 3.788. So this gives us less than 0. F of 3.788 gives us less than 0, and the other one will keep it as it is. If at all a new x value was giving us greater than 0, then we would have replaced what was greater than 0. But since we had less than 0, we are replacing the interval which gave us less than 0 in the previous interval. Now this is a new a, this is a new b. Now with this, let's find out x2. x2 is 3.788 into f4 minus 3.788 minus b into f of a, right? B is 4. 4 into f of 3.788 divided by f of 4 minus f of 3.788, which is equal to 3.789. Now what is f of 3.789? It is equal to minus 0.001. This is again less than 0. So minus 0.001 is again less than 0. So now what are we going to do in our next iteration? Since a new x value is giving us less than 0, whatever was giving us less than 0 in the previous interval, that we will replace with a new x value. So 3.789 comma 4. So this f of 3.789 gives us less than 0 and f of 4 gives us greater than 0. Now this is a new a, this is a new b. Now x3, we will be finding out x3. Now what does this new interval mean? Previously we knew that the root is between 3 and 4. Now later we have shrunk the interval and we came to know that the root is between 3.788 and 4. Now further we shrinked and now we know that the interval or the root, we know that the root is between 3.789 and 4. Now let's find out x3. x3 is 3.789 into f of 4 minus 4 into f of 3.789 divided by f of 4 minus f of 3.789. So this value is 3.790. Now f of 3.790 is 0.001. Now this is greater than 0, right? So if that is greater than 0, what do we have to do in our next iteration? What was giving us greater than 0 in the previous interval? F of 4, right? So this was greater than 0. So we will replace our new x with this number. So it's now our next interval is 3.789. This is as it is because now we got greater than 0, right? So we are going to replace the one which gave us greater than 0. So 3.789 comma, what is our new x value? 3.790. Okay, so this was giving us less than 0, this was giving us greater than 0. This is our new a, this is our new b. Now x4 is equal to 3.789 into f of 3.790 minus f of minus 3.790 into f of 3.789 divided by f of 3.790 minus f of 3.789. So this was our a, this was our b, right? A into f of b minus b into f of a divided by f of b minus f of a. Now our x4 value is 3.790 again. Okay, so previously also we got x value as 3.790. Now also we are getting it as 3.790. So if at all we are getting the repeated x values, we can say that this is our root. Or if at all we have got f of x is 0, then also we can say that this is our root. So either ways. But here we got repeated x values, right? So this is our root. So since this third iteration x value and fourth iteration x value is same, we can say that the root is 3.790, and we have corrected to 3 decimals as asked in the question. So I hope this is helpful. Please subscribe if you have found it useful. Thank you.